What's up, calculus students? Listen to homework video on log x. What we learned is that the log function's derivative actually deals with its x values. E to the x's derivative is all about the y values of e to the x. Log x inverse, x values. We'll talk more about inverses and derivatives next class. Um, so I asked some questions just to try to trip you up, but they're all the same. Instantaneous rate of change of a function, tangent slope. Slope of the tangent, tangent slope. This is just what's the derivative? What's the derivative at 2, at 3? What's the derivative at 4? What's the derivative at e squared? Some things to note, like if I ask you what the log of 3 is, you don't know what that is. But if I ask you what the log of e to any power is, logs and e's will undo each other and just give you the power. You need to know that. That includes the natural log of 1. The natural log of 1 is 0. Why is that? Because e to the 0 is 1. So that's how we show that the natural log of 1 is 0. All right, the first two are just like questions that I want us to make sure we're comfortable with, because like this constant times this function, when taking a derivative, you don't have to worry about the constant. I don't have to use the product rule here. If I did, I'd get 0 is the derivative of 3 times log x, which goes away. And then it's just the derivative of log x times 3. So it's just 3 times the derivative of log x, which is 3 times 1 over x. And then I plug in 2 to find the instantaneous rate of change, which is 3/2. This is the slope of the tangent to this. It's telling me that that function's increasing because the derivatives are positive. If I have log x over 3, I don't have to use the quotient rule. You can rewrite things as 1/3 times the natural log of x. And then taking the derivative, just leave the constant. Derivative of 1 over x, plug in 3. Derivative of log x is 1 over x, plug in 3. Okay, that's telling me this function is increasing by 1/9 y per x at x equals 3. All right. We'll get to that one. That's important. These are important. So we got a good amount of them. The chain rule also applies. Product rule applies. If you have something inside the log function, we like to do an O and an I for it, where the derivative of log parentheses is 1 over parentheses, the derivative of 2x is 2. But watch what happens when I write down this derivative. I'll have 1 over whatever started stays times 2, which actually simplifies to just be 1 over x. Plug in 4. I get 1/4. That's the slope of the tangent. This function is increasing because this is positive. All right, I got e squared that I have to plug in. This is a product. I have to use the product rule. So derivative first times the second plus the derivative, derivative first times the second plus the derivative of the second times the first. 1 over x times x, that's just 1. So I get log x plus 1. And I'm going to plug in e squared into this. Log of e squared plus 1. The log of e squared is just 2. 2 plus 1 is just 3. Is f increasing or decreasing at the given value? So let's look at the slope of the tangent. If it's positive, f is increasing. If it's negative, f is decreasing, right? It's the whole, if f prime is positive, f is going up. If f prime is negative, f is going down. Analysis, but just at a point, which means you don't have to do a full sign analysis. You just have to figure out what the sign is at this point. Now, this log x over x, I have to use the quotient rule. The derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. I'm going to change this for fun. If you did it as it was asked, you get 1 minus log x over x squared. If you plug in e, it's 1 minus the log of e over e squared. Log of e is just 1. So you actually get 0, which means you're constant. You're neither increasing nor decreasing. If I plug in e squared, this is e squared squared, which would be e to the fourth. This is kind of more like what I wanted you to get, which is 1 minus 2 over e to the fourth, which is negative 1 over e to the fourth. That's a negative. So at x equals e, h is constant. Oops. At x equals e, h is constant. At x equals e squared, h is decreasing. It's decreasing because the slope of its tangent is negative. Okay, another chain here. So O's and I's. Log parentheses the O, x to the fourth is the I. It's nice that like the logs do have parentheses, so it's a little bit easier than e to a power to recognize that you need to use the chain rule. So I have 1 over x to the fourth times 4x cubed. Now, you could write this as 4x cubed over x to the fourth. And realize that 3 of the x's cancel. So you just have 4 over x. Plug in 2. 4 over 2 is 2. So r is increasing. Why? Because its derivative is positive. Okay, this is a good one because, I don't like 1. Well, whatever. We do have a chain here, but the outside is the cube. The inside is the log x. Derivative 3 stuff squared, the derivative of log x 1 over x. Now, why don't I like this one is because when I plug in 1, I'm going to get 0. So that means we're constant. So maybe I'll change this up too. So I have 3 times whatever started in the parentheses squared times 1 over x. Plugging in 1, you need to be comfortable with the log of 1 equaling 0. Again, the log of e to the 0 would just be 0, which is why the log of 1 is 0. So this is 0, and I'll just leave it there. I'll just say m is constant. It's flattened out. Ooh, let's look at this one. Another O and I. O is the log. I is the cosine. Derivative would be 1 over. Derivative of cosine is negative sine. So Q prime would be 1 over cosine times negative sine. What you realize is this ends up being just negative tangent. Okay, but like, whatever. If you don't want to do that, you just plug in pi over 3. And it's the same thing. You have to find sine of pi over 3, the cosine pi over 3, divide them. That's tangent, y over x. Sine of pi over 3 is root 3 over 2, so I have negative root 3 over 2. Cosine of pi over 3 is 1/2. I end up with just negative root 3, which is negative, which is telling me q is decreasing. Because q prime at pi over 3 is negative. Q is decreasing just at x equals pi over 3. Okay, that's good. Equations of tangent lines. Ooh, log x. That's going to be a fun one. Okay. We need a point on the function. We need the slope of the tangent at that point. The point's 1, so leave that. I got an O and an I again. Log parentheses the O. 4 minus 3x squared is the I. Derivative 1 over. Derivative negative 6x. So f prime is 1 over 4 minus 3x squared times negative 6x. I can't simplify this with this. Like I can't simplify the 6 and the 3, the x and the x squared because of the subtraction here. So make sure we don't simplify when we can't. It's only when things are multiplying all over the place. If I could factor something out, maybe then I can have multiplication and simplify that. But I don't. All right, so let's find the point. If I plugged in 1, I get the log of 1, which is 0. So I have the point 1, 0. Let's find the slope. I plug in 1. I get negative 6 over 4 minus 1, or 4 minus 3, which is 1. So the slope is negative 6. Okay. Let's plug in negative 1 to start. 1 minus negative 1 is 2. I can't simplify that. Log of 2, you just have to leave. So if it's log of an e to a power, which includes log of 1, you know what that is. Everything else, you don't know, so you just leave. Find the derivative to find the tangent slope. I got log, I got 1 minus x, so I got a negative 1, and I have a 1 over. So f prime is 1 over 1 minus x times negative 1. F prime of negative 1 would be negative 1 over 1 minus negative 1 is 2. So my slope is negative 1 half. So I have y minus the y coordinate log 2 equals my slope of my tangent, x plus 1, which is x minus negative 1. Good one. Watch what happens when I plug in e. Get log of e. The log of e is 1. The log of 1 is 0. So I have the point e0, another 0 point, but you got to make sure you know how to get there. Now watch this derivative. This is fun. It's an o and an I. O being the log function, the I being ln(x), the log function as well. It's like log parentheses and then log x. This derivative is 1 over x. This derivative is 1 over parentheses. Okay, this might be tricky, but let's see if we can get it. 1 over what started in the parentheses times the derivative. So it ends up being 1 over like x log x. Plugging in e, I have 1 over natural log of e's, which is 1 times 1 over e. So that's just 1 over e because this is just 1. Giving me y minus 0. I don't have to put that, but I'm putting it anyways. Slope 1 over e, x minus e. Cool. Cool. What's f double prime of e cubed? And what does that tell you? Okay. Well, let's find the second derivative. First derivative, I have to use the chain rule. You can either leave off the 1 half or just put it in the outside. Inside is log x. The derivative would just be stuff to the first power because it's like the 2 comes down, it's the power rule, and then subtract 1. Derivative of log x is 1 over x. So f prime, the first derivative, is whatever started in the parentheses to the first power times 1 over x. I'm going to rewrite that as log x over x because it'll be easier to use the quotient rule here than to use the product rule with a negative first power. Both can be done. If I want to take the derivative of log x over x, we did this. It's the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared, which simplifies to be 1 minus log x over x squared. And let's plug in e cubed. F double prime of e cubed is 1 minus log e cubed over e cubed squared. What's e cubed squared? It's e to the fifth, it's e to the sixth. Power to a power, we multiply. E cubed twice. E cubed times e cubed, e to the sixth. Now, log of e cubed is 3, so I have 1 minus 3 over e to the 6, which is negative 2 e to the 6. What does that tell me? Well, it tells me the second derivative is negative. It tells me 2 things. It tells me really more than 2 things, but 2 things that are kind of important to the original function. It tells me that f prime is decreasing at x equals e cubed. It tells me f is concave down add x equals e cubed, right? Second derivative sign being negative means the first derivative is going down, means the original function is concave down. This is a good question. We haven't seen this since Unit 2, like this notation much. This is notation for y prime. This would be notation for y triple prime. So I'm given y prime. I need y triple prime. I need to take the derivative 2 more times, not 3 more times, just 2 more times. For both of these, I need to use O and I. O here is sine, I is 2x, so I got cosine and 2. O is log, I is 3x, so I have 1 over times 3. We'll see how that simplifies. So taking the derivative of my first derivative gives me my second derivative. This gives me y double prime. I have cos 2x times 2 minus 1 over 3x times 3, which is just 1 over x. The 3's cancel because of the multiplication of everything. Now, if I take the derivative of this to get the third derivative, d cubed y over dx cubed would be, I got to go O and I again. You can move the 2 in front. The O could be the 2 cos parentheses. The I is 2 over x. So I get negative 2 sine parentheses and 2. And then the derivative of 1 over x, you can either use the quotient rule, but it's better to rewrite as x to the negative first. And then the derivative would be negative 1x to the negative second. So here's my third derivative. Let me give myself some space here. I have negative 2 sine 2x times 2. I had a minus here, so minus the derivative of x to the negative first would be negative 1x to the negative second. I'm going to simplify this a little bit. The 2's can be multiplied together. And here the minus a negative turns into plus a positive. And then the x to the negative second turns into 1 over x squared. Okay, so this is my third derivative. All right, so more Unit 2 review. We had piecewise functions. It's really like Unit 1 / Unit 2. And there's two things like we checked with piecewise functions. We either made sure they were continuous. That was Unit 1, checking continuity. And then in Unit 2, we checked if things were differentiable, which means our pieces meet up, but they meet up in such a way so that they're smooth, so that we don't have a sharp point. And if we have a sharp point on F, F is not differentiable. Okay, a lot of people got confused with Unit 3's test. It's like sharp points on F prime. Oh, that means F is not differentiable? It's like, no, you're allowed to have sharp points on F prime. That's fine. Okay, so you can't have sharp points on F. So the first three questions are about the continuity. If you remember, it's just like making sure the pieces meet up, making sure the first piece, when I plug in 1, I stop plugging in 1, meets up with the second piece at 1. Okay, it's like doing the limit if I'm plugging in like 0.999999, but if I'm plugging in 0.9999, I'm going to approach the value where this is at 1. So I just plug in 1. So anyways, you plug in 1 for x, you get b minus 3. You plug in 1 for x, you get 4 log 1. You need to know the natural log of 1 is 0. So I get b minus 3 equals 0. B has to equal 3. That's easy. Let's try this one. This is interesting. My first piece needs to meet up with my second piece at e, the important x value. So f little 1 at e needs to meet up with f little 2 at e. All right, so I got 2a over e times e minus 3 equals 4 log e plus 2. All right, well, the e's cancel, just gives me 2a minus 3. Natural log of e is just 1. The log and the e cancel, leave us the power. The power is just 1. So I have 4 plus 2. So I have 2a minus 3 equals 6. Add 3, divide by 2, a equals 9 halves. All right, this is the same thing. First little piece at the natural log of 3 needs to equal the second little piece at the natural log of 3. Hold on. All right, so I got a e to the ln 3 equals 4 over ln 3 times ln 3 plus 2. E to the ln 3, again, they're like the square roots to the square. It's the square to the square root. They undo each other. It's just 3. So if a times 3 equals 4 plus 2, that's 3a equals 6. That's a equals 2. Cool. Now, our questions are make sure the function is differentiable. So not only do I have to do what I just did, which is to make sure the pieces meet up, but I have to make sure, so make sure they're continuous, but I have to make sure that there's no sharp points. To ensure there's no sharp points, we're going to have to make sure that the slopes, the slopes of the two pieces are the same at that x value. Okay? So we're cool with b minus 3 equals a log 1, which is 0. B equals 3. Again, this is a log 1, which is 0. I always try to skip things, and then I'm like, oh, I can't skip it because somebody might be confused about things. Log of 1 is 0. Log of e to the 0 is 0, so the log of 1 is 0. So get b. Now, taking the derivatives and then plugging in 1. The derivative of bx squared minus 3, b is just a number, 2bx. The derivative of a log x, a is just a number, would be a times 1 over x. We then need to plug in 1 for x. 2b equals a. We already know what b is. B is 3, so a is 6. Okay? So, like I said, the first two lessons are a repeat of what we've done, just with e's and logs. Here is the repetition of the piecewise functions. Didn't have any of these in the e to the x lesson, but I could have. And look, here's an e to a power. So it's it is a repetition. All right, so check the continuity. Plugging in 1. F little 1 at 1 needs to equal F little 2 at 1. I have a times e to the 4 minus 2 equals b log, that'll be 1. That's e to the 0, which is just 1. E to the 0, anything to the 0 is 1. So I have a minus 2 equals, log 1 is 0. Okay, I get a. A is 2. Now, can't have a sharp point when we meet up, so my slopes need to meet up. Okay, so the derivative of a e to the 4x minus 4 minus 2. I'm going to have to use the chain rule here. A being just a constant, I could just forget about it and worry about it afterwards. But the power does matter. Now, the derivative of e to the parentheses is just e to the parentheses, but then the derivative of 4x minus 4 is 4. So the derivative of my first little piece is a e to the 4x minus 4 times 4. The derivative of minus 2 is 0, so make sure you remember that. Don't include the minus 2 because its derivative is 0. Now for b log 3x minus 2, it also has an o and an I. B is just a number, so I'm going to say the outside is b log parentheses. Inside's 3x minus 2. The derivative is going to be b over parentheses, or b times 1 over parentheses. And the derivative of 3x minus 2 is just 3. So I have b over 3x minus 2 times 3. Great. What do we do now? We take 1, we plug it in for x. I don't know if this will work. Let's see. Again, I have a e to the 0 times 4 equals b over 1 times 3. 4a equals 3b. A is 2. 8 equals 3b. It does work. B equals 8/3. Sweet. All right, now we get into Unit 3. We're going to do sign analysis of these functions with logs, just like we did with these. Um, Key to these are solving and then using correct test points to help you. Okay? The rest of the process should be familiar and the same, but then it's not as easy as just like factoring like we're used to. So it ends up being something new. Okay, so first thing, we got to take the derivative correctly. We got to make sure we use the product rule here. Derivative of the first times the second plus the derivative of the second times the first. Again, negative log x plus negative 1. When does that equal 0? And it's like, what do I do? Well, like, I'm going to have to solve this equation. I'm going to have to add 1, maybe divide by a negative, and then I have to solve for x. How do I do this? Okay, well, solving for x in logs means use the inverse, use the square root to the square, but the inverse to undo is to take e to the power of both sides. Okay, e to the power of log x. It's not e times, it's e to the. Very important. Like e to the x will undo log x. So I got to put like e to the log x to get x, or ln of e to the x just gets us x. All right, so e to the log x just gets us x. And I get x equals e to the negative first, which is 1 over e. And it's like, okay, great, but like what? 1 over e? Another thing, x is bigger than 0. I'm not allowed to plug in 0 into the log. I'm not allowed to plug in any negatives into log, so I have to start somewhere. Now, how do I test my signs? Okay, well, let's start with our simplified f prime. Now, it's not factored anymore. It's just that. Okay? It's got log in it. What do I do? Well, I'm going to take numbers that I know I can plug in to the log function. But that's not like 5, because I don't know what the log of 5 is. It's like e's to powers. The log of e to any power would be a power if the log of e to the x is just x. Watch what I'm going to do. I know this is e to the negative first. Why don't you plug in? Not 5, but e to the 5th. Now, when I do that, watch, I got negative log e to the 5th plus negative 1. E to the 5th, log of e to the 5th is just 5. So I have that negative 5 plus negative 1. That's negative 6. Those are negatives. Okay? But what about a value here? What can I plug in? Well, let's take e to a large negative power. Like 1 over e to the 5th is smaller than 1 over e. It'll be closer to 0. Now watch what happens when I do that. I have negative log e to the negative 5th minus 1, or plus negative 1. Log of e to the negative 5th is negative 5, so I have the opposite of negative 5 plus negative 1. That's positive 5 plus negative 1. That's positive 4. That's a positive. So the question is, when is f increasing? F is increasing when f prime is positive. F will be increasing from 0 to 1 over e. Okay? Different, new, but we can do it. Same thing here. When is f decreasing? Okay, well, I have to take the derivative here using the quotient rule. Derivative of the top times the bottom minus derivative of the bottom times the top all over bottom squared. Now, we've been setting things equal to 0. We've been negating and like forgetting about the whole undefined part, but it's still important, and it's actually important here because the denominator equals 0 at 0, which means 0 is technically like a critical point. However, I can't plug in 0 into my original equation. So for this situation, in reality, it's not a big deal because I'm starting at 0 anyways. What I need to do is solve, really just when will the top equal 0? Okay, like I don't want to multiply by x squared. That'll like get rid of the whole fact that I need to think about 0. But we are already talking about x is bigger than 0, so we don't have to worry about it. So really, we just worry about the top equaling 0. Now, how do you solve this equation? Well, maybe you subtract 1, take the opposite of both sides. Maybe you add the log x to both sides. And then, how do you solve? E to the power of both sides. Now, in this situation, I get x equals e to the first. Okay, so on my number line, I'm going to start at 0. I'm going to focus on e. Now, when this happens, and you have e, there is a nice, easy number, whole number, that we can plug in, 1. Why is 1 an easy number to plug in? Because 1 is the same as e to the 0. And watch, if I plug in e to the 0, which is 1, I know what that is. That's 0. 1 minus 0 over 1. That's positive. Now, what about to the right of e? Well, plug in e squared, e to the 5th. Plug in something that's easy to plug into the natural log function. I don't even have to worry about the denominator. Like, take a number squared. It's always positive. So, like, whatever. Just worry about the numerator, really. So, like, whatever. Log of e to the 5th is 5. It's really 1 minus 5, which is negative. So, boom. When is f decreasing? F is decreasing when its derivatives are positive. So you can either say e to infinity or x is bigger than e. All right. Then we go into some first derivative and second derivative sign analysis. This one I'm given f. This one I'm given f prime. So we'll be careful with that one. I already took the derivative of this, so you can look back and how to do this. It ends up being log x times 1 over x. So that's log x over x. Okay, and I need to like see when that's 0. Well, again, I would worry about the denominator equaling 0. That is at 0, but I'm not allowed to plug in anything less than 0, so like I don't have to worry about it. Just have to worry about the numerator, log x equaling 0. What's that? Well, like we've talked about it enough, you should know, but here's how you can show it. E to the 0, which is 1. 1 is our important point. Now, what should I plug in? Well, now that I have 1 as my 0, I do need to plug in e to a big negative power. That's between 0 and 1. 1 over e cubed is obviously less than 1. It's like 1 over, 27, something around there. Plugging it into log x over x, which is my first derivative. I'd get negative 3 over e to the negative third. E to any power is always positive. This really can be written as negative 3 times e cubed. That's negative because of the negative 3. If I plug in e squared or e cubed, I guess that's a square. 2 over e squared. 2 over e squared, obviously, positive. All right, so here's when f is increasing. Now let's figure out when f is concave down. I need a second derivative. I will use this first derivative, use the quotient rule to get my second derivative. Derivative of the top times the bottom minus the derivative of the bottom times the top. All over the bottom squared. So I'm familiar with this. This 1 minus log x over x squared. Didn't I just have that? 1 minus log x over x squared. So it's like I can literally just repeat what I just did. Now, maybe you like copied this down from my video. Maybe do this right now. Like solve. Do the analysis yourself. You worry about when the top equals 0. E to the power of both sides, you get x equals e. E is bigger than 1, so put it to the right. This is f double prime. Again, we're starting at 0. Plug in a value, maybe like 1, maybe like e to the negative third, something like that, into my second derivative. 1 minus the log of 1 over 1 squared. 1 minus the log of 1 is 1 minus 0. So that's positive. Plug in something like e squared. 1 minus the log of e squared over, I know it's something positive, so I'm just going to put a positive there. 1 minus 2, that's going to be a negative. Okay, so when is f increasing? Here is when f is increasing. When is f concave down? F is concave down when f primes are decreasing, when f double primes negative. So we're actually looking at x is bigger than e again. Maybe I should ask increasing concave up, and increasing concave up would be between 1 and e. But if you have the analysis, then you're fine. But for this question that I asked you, it would be between e and infinity when f double prime is negative and f prime is positive. Okay, this one I'm talking about x is bigger than 3. So I need, for both f prime and f double prime, I need to start at 3. That's interesting. Let's see how that works out. Now I'm giving you what f prime is equal to. So you want to do a sign analysis of f prime? Well, don't have to take a derivative. Just got to start with that equal to 0. Take e to the power of both sides, frees up the x minus 3. 4. Okay. Now, to get our second derivative, we'll take our derivative. We'll need to use the chain rule, but it doesn't matter because the derivative of the inside is just 1, so I just get 1 over x minus 3. That's never 0. That could be undefined at 3. But what's it's saying is that, like, plug in something like 4 or 5 or 6 or something bigger than 3, 1 over x minus 3 is always positive. Okay? Here is tricky. Like, what do I plug into log x minus 3 between 3 and 4? I mean, you want to get like an e to a power, but it's like tough to get e to a power because it's x minus 3. It's almost as if, like, you're looking at log x, which is centered at 1, and you're thinking about plugging in like e to the negative second, which is like less than 1 but greater than 0. It's like the same idea. I don't want you to worry about this one that much, because it's not obvious to plug in a certain value and to get negatives and positives. I feel like you could do the analysis that, like, the log of a very small number, some decimal, is going to be negative, and then the log of a big number is going to be positive. And so don't worry about it. It's not going to be on your quiz. F is increasing. F is concave down. Never. So change this to decreasing. Concave up. And you'll have your answer 3 to 4. Not a great question. Don't worry about it. All right, finishing off with some table problems. Again, Unit 2 stuff. Making sure you know notation matters, derivative rules matters. Log of f of x, to take its derivative, you'd have 1 over f of x times f prime of x. So g prime is 1 over f of x times f prime of x. Very important to get that right. Use your O's and your I's. Plug in 1. F prime of 1 is negative 1. F of 1 is 3. So I get negative 1/3. Oh, this is a good one. Log of f of x squared. Guess what? We haven't seen this since Unit 2. We got OMI. We got an outside. We got a middle. And we got an inside. It's been a while since this. I didn't give you any of those with ease. Should have, but didn't. Kind of weaning you back into remembering all this stuff. OMI. Multiply all the things together. Here's P prime. Whatever started in logs parentheses, f of x squared stays. Whatever started in f's parentheses stays. And then you got this 2x at the end. Fortunately, I get to plug in 1, which gives us 1 over f of 1 times f prime of 1 times 2. So it's really the same as got negative 1/3 times 2, which is negative 2/3. Product rule. Derivative of the first times the second plus the derivative of the second times the first. Plugging in e, I get f prime of e log e plus 1 over e f of e. Log of e is 1. F prime of e is negative 3. F of e is 2. I don't know, I'll probably just leave it like this. You could make this a 3e over e to make this negative 3e plus 2 over e. You can't simplify those e's. But, either this or this is fine. And then quotient rule to finish off. Derivative of the top times bottom minus the derivative of the bottom times the top all over bottom squared. Plugging in e again, I'll have f of e over e minus f prime of e times the natural log of e, which is just 1, over f of e squared. So f of e 2, f prime of e negative 3. Over e minus negative 3 over 2 squared, which is 4. I don't know. Leave it like that. That's fine. Want to simplify? It's 2 plus 3e over 4, which is 2 plus 3e over 4e. Multiply the denominator by 1/4. We'll multiply this by 1/4. Dividing things, same as multiplying by the reciprocal. So 2 plus 3e over 4e. All right. That's it. Whoa! You probably didn't have to do this homework. It ended up on a no homework night this year. So hopefully you do maybe watch this video a little bit. And that's it. We'll see you next class.